The second thing that I had to go over was the geometry. So with the geometry, I'll tell you that the best thing to do whenever you're dealing with a geometry problem like that one, so geometry problem like this one, the best thing to do is to draw as many auxiliary figures as you can think of until what you're seeing makes sense. I will, admit that I've never taught geometry, and I'm kind of glad I didn't, because I think geometry is a difficult subject to teach. Not difficult subject for necessarily everyone, but with a lot of people, with geometry, it comes down to either you get it or you don't. And for people who don't get it, it's at least as far as it comes up in physics, I found it difficult to explain things in geometry to people who are not seeing it. It's like getting a joke or whatever. If you get it, great. But to people who don't get it, you keep trying to explain it, and it never works. So let me just draw some figures again so that I have something to draw. So I had this point. Well, I didn't draw this circle well. Let me just try to keep fixing it so that it looks reasonable. I want it to look kind of vertical here. All right, so I have this point here, and I have another point here. This is point 1. This is point 2. And I had two velocity vectors at these 2 points. Velocity vector pointing this pointing vertically up, v1, and velocity vector here pointing this way. Yep. And where that figure that's drawn there comes from is that I took this vector, let's say draw it here independently, so that I can see the geometric relations more easily. And I took this and I translated it over here. So that right now in this figure, they start at 2 different points. That makes it harder to see what the relationship between the 2 vectors are. So I made them start at the same point. And all of this is allowed from the property of, property of vectors that we've been talking about, right? When I translate a vector, I haven't actually changed anything. And the reason I was drawing this figure was so that I could figure out what was the change, delta V, what was the change in vector. And to figure this out, I needed to know what is this angle. And that's where the geometry exercise comes in. Ideally, I'd like to be able to relate this angle to this angle here, because this is the angle that's given to me. Okay? So I go through some auxiliary figures, trying to see what everything else here is related to. There's one directional relationship that's good to know. Anyone here know when you're dealing with a circle, the relative direction between, I don't know, vector that's tangent to circle and any other direction that's related in some way? Could you say a lot? Someone saying position. No, I'm not asking about how you get velocity from. I'm asking about, I have this, think of it as a line. I have a line that's tangent to the circle. And I'd like to be able to describe the direction of that tangent line. Anybody here know what other direction in the circle that's associated with and how? Once again, this is a geometry exercise. No velocity, no acceleration, no positions. This is a purely geometric exercise. No physics. It's a purely geometry. So when I have a tangent line, what else is that related to?
Perpendicular to the line that
Yeah, the radius connecting from circle to the point where it's a tangent. This is perpendicular. Everyone here knows that from geometry, right? Yeah. Once again, this is a geometry exercise. That's why I skipped this last time, because I was out of time and I'd rather cover physics than. But now I have time, so I'm going back over this. So this is perpendicular. Let me draw some auxiliary figures to help me figure this out. So I'm going to transfer this line over here. So I have some reference point in this final figure that I'm looking at. Well, it says this is perpendicular. All right. There's another line that's like this. That's this one. That's connecting the center to this other point. Let me just draw a representation of that. And from the same thing what Abdi was talking about, this line is perpendicular to the tangent line, tangent at point 2. So that means this is 90 degrees. Good? Now, I do know a relationship between the directions of these two lines. They are related, they are at rotated theta from each other. That's what this was, right? So, looking at this figure, can you figure out what other angles are theta? That's really what it comes down to. So let me, go through some of the angles that might be equal to theta. This is equal to theta. Not that it helps me, but it's equal to theta. Now this angle, that's not equal to theta. That's pi over 2 minus theta. Right? 90 degrees minus theta. But I know this entire thing is 90 degrees because this is 90 degrees, which means this is, pi over 2 minus theta. So this should be theta. Yeah? So this is, when you draw a proper diagram with all the auxiliary figures, this is really similar to the geometry exercise you've been doing when you break down forces into components. So it's surprisingly similar. So that's why this angle between the two vectors is theta. Yeah? Any questions? All right, so let me explain the last bit about small angle approximation. Yes, I guess I should. I will title this circular motion geometry. I don't have a good title for it.